Hello, and welcome to this lesson on calculating the mean rate of a chemical reaction. In today's lesson, we will learn the equations used to calculate the mean rate of a chemical reaction. So far, we've explored the fundamentals of collision theory and recognized that increasing the number of collisions speeds up the reaction rate. We then explored the factors that influence reaction rates. Building on this foundation, today's lesson will advance our chemical understanding by introducing quantitative methods to measure and analyze reaction rates, providing a more precise and numerical perspective on how reactions progress over time. The rate of reaction is essentially how fast it proceeds. We know that the rate of a chemical reaction depends on how often and how energetically reactant particles collide, which is essentially what collision theory explains. However, to make this understanding more robust, we need to quantify these reaction rates using mathematical expressions. To find the mean rate of reaction, we use the following formula. The mean rate is equal to the quantity of reactant used over the time taken. Alternatively, we can determine the mean rate using the product formed. This equation states that the mean rate equals the quantity of product formed over the time taken. Consider a reaction where calcium carbonate reacts with hydrochloric acid to form calcium chloride, carbon dioxide, and water. Let's say we measure the amount of carbon dioxide produced. If 24 grams of carbon dioxide are formed in 12 seconds, we can calculate the mean rate of reaction as follows. The quantity of product formed is 24 grams of carbon dioxide, and the time taken for the carbon dioxide to form is 12 seconds. Therefore, the mean rate of reaction is 24 grams divided by 12 seconds. This means that, on average, 2 grams of carbon dioxide are produced per second during the reaction. Let's dive into some GCSE level questions to apply what we have learnt. Question 1. Magnesium reacts with hydrochloric acid to produce magnesium chloride and hydrogen gas. If 12 grams of magnesium react completely in 6 seconds, calculate the mean rate of reaction in grams per second. Pause here to have a go. Now, let's go through the answer. Firstly, identify the quantity of reactant consumed, which is 12 grams of magnesium. Next, identify the time taken, which is 6 seconds. Then, use the equation for mean rate. Seeing as we have the amount of product formed, we will use the equation with product formed in it. Now, substitute the values in. The mean rate is 12 grams divided by 6 seconds, which gives an answer of 2 grams per second. This means that, on average, 2 grams of magnesium react per second. Question 2. In the decomposition of hydrogen peroxide, 20 grams of oxygen gas are produced in 10 seconds. Determine the mean rate of reaction in grams per second. Pause here to have a go. Now, let's go through the answer. First, identify the quantity of product formed, which is 20 grams of oxygen gas. Next, identify the time taken, which is 10 seconds. Then, use the equation for the mean rate. Once again, this is the quantity of product formed divided by the time taken. Now, substitute the values in. The mean rate is 20 grams divided by 10 seconds, which gives an answer of 2 grams per second. This indicates that, on average, 2 grams of oxygen gas are produced per second during the reaction. Let's tackle a slightly more complex problem. During a reaction, the mass of a reactant decreases by 10 grams over 5 minutes. If the relative molecular mass, mR, of the reactant is 50, what is the rate of reaction in moles per minute? Pause here to have a go. Now, let's go through the answer. Since we need an answer in moles per minute, we need to first calculate the moles of reactant consumed using the formula. Moles equals mass over mR. Here, the mass change is 10 grams and the relative molecular mass is 50. Then substitute the values into the formula. The moles of reactant are equal to 10 grams divided by 50 grams per mole. This gives 0.2 moles of reactant consumed. Next, find the rate of reaction by dividing the moles by the time. Time is given as 5 minutes. So, to calculate the rate, we divide 0.2 moles by 5 minutes, giving us an answer of 0.04 moles per minute. This means that, on average, 0.04 moles of the reactant react per second. Let's look at one last question. Question 4. A reaction carried out at room temperature and pressure produces a gas, and the volume of the gas increases by 48 cubic decimeters in 2 minutes. Calculate the rate of reaction in moles per minute. Remember that, at room temperature and pressure, 1 mole of gas occupies 24 cubic decimeters. Pause here to have a go. Now, let's go through the answer. Again, we need to first calculate the moles of gas produced. This can be done using the molar gas volume. Moles equals volume divided by molar volume. Here, the volume change is 48 cubic decimeters, and the molar volume is 24 cubic decimeters per mole. Substitute the values into the formula. Moles equals 48 cubic decimeters divided by 24 cubic decimeters per mole. This gives 2 moles of gas produced. Next, find the rate of reaction by dividing the moles by the time. The rate equals moles divided by time. Time is given as 2 minutes. Therefore, the rate is 2 moles divided by 2 minutes, giving 1 mole per minute. Hence, 1 mole of gas is produced every minute. By working through these examples, you can see how to consistently apply the formula for mean rate of reaction, whether using the quantity of reactant consumed or the quantity of product formed. In today's lesson, we delved into the methods for calculating the mean rate of a chemical reaction, focusing on both the quantity of reactant consumed and the quantity of product formed over a specified time interval. We introduced the key equations. Mean rate equals the quantity of reactant used divided by the time taken, and mean rate equals the quantity of product formed divided by the time taken. This lesson has equipped you with the quantitative tools needed to precisely measure and analyze reaction rates, building on your foundational understanding of collision theory. Watch the rest of the GCSE chemistry course at Sophos Education.